Good morning everyone. Today I am going to discuss about the 16th. Generally here I am discussing 15th group elements. 15th group elements also called as nitrogen only. Today I am going to discuss about nitrogen family, which are located in the P block element. You know very well the P block elements are nitrogen family will be there, oxygen family will be there, halogen family will be there, and noble gas family will be there. In that one I am discussing about the nitrogen family. Nitrogen family generally comes under the 15th group elements are there. This is also called as 50th group elements. This is also called as a 50th group elements. Nitrogen family also called as a nicogens. Nicogens means suffocating producer. Suffocating. What suffocating means? Generally the oxides of nitrogen, phosphorus, arsenic, they have the tendency to produce suffocation. We cannot respire properly. That's called as a the nicogens. They are suffocating order only. Generally, when you come to the general metallic, non-metallic nature of nitrogen family include of the both metals, non-metals, and metallites. All three categories of elements are located in this group only. General nitrogen, phosphorus comes under the non-metals only. Arsenic, antimony comes under the metallites only. Bismuth comes under the metal only. Bismuth comes under the metal only. Once again repeating the nitrogen, phosphorus, non-metal, arsenic, antimony, metallites, bismuth is metal only. Bismuth is metal only. Next, coming to the next slide is there here. Look at the here. What is mentioned? General electronic configuration. General electronic configuration nitrogen family only. General nitrogen family have general electronic configuration is NS2, NP3. They have the 5 electrons in their outermost orbital. That's why coming as a 15th group element cell. Because of 5 electrons in the outermost orbital, there comes under the 15th group element only. Coming to nitrogen second period, the general electronic configuration of nitrogen is 2s2, 2p3. Phosphorus is third period, general electronic configuration is 3s2, 3p3. Arsenic is fourth period, general electronic configuration is 4s2, 4p3. Stibbium is the fifth period, general electronic configuration is 5s2, 5p3 only. Bismuth is 6th period, general electronic configuration is 6s2, 6p3. These are the general electronic configuration of the nitrogen family only. General electronic configuration of the nitrogen family. Next, coming to the oxidation state. Okay, how many electrons are loses when they form a bond only. Whenever generally these elements are take part in chemical reaction, and which oxidation state is more stable form also can say. Once again repeating here, whenever these elements are take part in chemical reaction, which oxidation state is more stable? Nothing but look at it. Okay, we discuss here. Then remember here the nitrogen having the look at here nitrogen having the 3 electrons deficient to attain the octet configuration. General nitrogen having the 3 electrons. Look at here the NP6 will come means it attain the noble gas configuration. So in order to attain the noble gas configuration, 2 possibilities. Either these elements can lose the 5 electrons or the possibility of gaining up the 3 electrons. That's the reason why generally non-metals are electronegative nature or no. We can see the common oxidation state is -3, -3, -3, -3. But bismuth is a metal. Bismuth is a metal because of inert pair effect. What is inert pair effect means? Here the NS electrons are NP electrons are there. Here the NS electrons doesn't take part in chemical reaction. NS electrons doesn't take part in chemical reaction. That's the reason what happened there is only NP3 electrons take part in chemical equation. That's called inert pair effect. The reluctance shown by the N electron to take part in the chemical reaction is called as a inert pair effect only. Because of inert pair effect is bismuth exhibit the +3 oxidation is more stable oxidation state only. Along with the -3 oxidation state, there is a possibility of the losing of 3 electrons. There is a possibility of the loss of 5 electrons. Both is possible. Both is possible only. So look at the phosphorus also -3 +3 +5 oxidation state is available. Arsenic -3 +3 +5. Stibbium is -3 +3 +5. Bismuth is +3 -3 +5. Okay, it shows the -3 oxidation state because of the hydrogen. Look at when they combine the hydrogen NH3. If you know very well how to find the oxidation number, when you calculate the oxidation number of nitrogen, it comes as a -3. pH3 also it comes as a -3 only. Okay, now look at the why, because look at you know very well here the plus red color I mentioned is then because of the inert pair effect. Bismuth exhibit only +3 oxidation state is more stable oxidation state. Next, coming to the atomic radii. What is atomic radii means? Here the size of the atom only, no. What happens is consider that when any group is there, no, when you go for downward is there, no, atomic size increases. Why atomic size increases? Because of increasing of the n value. Because of increasing of n value, atomic size will be increases only. How can you say so atomic size increase n value means here? This one, remember one point. Look at the electronic configuration. The outermost electrons present in the second orbital, here third orbital, fourth, fifth, sixth orbital. So what I mean, the n or n value increases, atomic size of the elements is increases. So that's why when bismuth having highest atomic size, because of having the highest atomic size, what I mean, it acts as a metallic properties. Next, come to ionization enthalpy. What is ionization enthalpy? The minimum amount of energy required to remove electrons from the outermost shell. So look at I'm taking here because of look at here metal is there, here non-metal is there. So what happens here because non-metal in nature, to remove electrons from nitrogen is very difficult. And also remember, because small atomic size, the nuclear force of attraction is very strong, so very difficult to remove the electrons from the nitrogen. Later phosphorus, arsenic, bismuth, arsenic, stibinium and bismuth. Down the group, ionization energy value is decreases only. Down the group, ionization energy value will be decreases only. Next one is coming to the next point is here the allotropic form. What is allotrope means? In the same chemical composition, different physical appearance ka allotropes only. Nitrogen doesn't have any allotropes are there. Phosphorus, arsenic, antimony have the allotropes only. Do you know where phosphorus available in the different types of allotropes are there? White phosphorus, red phosphorus, black phosphorus, and scarlet phosphorus. Also there are sometimes also called as alpha black, beta black, violet. These are the allotropic forms of the phosphorus only. Because the white phosphorus is not like some books I have given is liquid, white color liquid. Some books I have given white color solid only. It will be glow on the night time. It is glow on the night time. Is very reactive. It will readily catch the fire only. Red phosphorus means that you are using black. You are using the mastic stone. No? The mastics not containing of the one red color part is there. No, red phosphorus only. Black phosphorus generally we are not using in our daily life only. Next one is the arsenic available in the form of the grey arsenic, yellow arsenic, black arsenic only. Stibinium was available in the form of the yellow, black, and explosive only. Okay, now consider here in our syllabus they have given only white phosphorus, red phosphorus, black phosphorus. They are more focused on the red phosphorus, white phosphorus, red phosphorus, and black phosphorus only. Next comes the covalence. What is covalence? Means number of bonds formed by the particular elements only. Okay, number of bonds. Look at when number of electrons shared in order to attain the octet configuration. Also can say that. Nitrogen general item saying not maximum. General nitrogen has covalence is 3. Why nitrogen having covalence? The remaining element having the 5 covalence means because of the lack of the d orbital. Because of lack of d orbital, nitrogen covalence is 3 only. Here phosphorus, arsenic, stibinium having the d orbital is there, no. So what is their covalence will be maximum. PCl5 is there. Okay, here look at the general oxidation studies. They know very well here +3 and +4 general oxidation. Here bismuth you know very well. Bismuth because of inert pair effect, covalence will become 3 only. Okay, here next one point is very important one. Maximum covalence of nitrogen is 4 only. How nitrogen coming 4 means you know very well nitrogen ammonia. Take ammonia. Nitrogen having the 5 valence electrons, 2 is the lone pair of electron, 3 involved in the bond formation. 3 bonds are there. This lone pair of electron donated to the one hydrogen atom by the dative bond. You know very coordination covalent bond only. Because of giving these 2 electrons, what happens they form a 1 bond. That's why around nitrogen how many bonds are there? 1, 2, 3, 4. It's nothing but here the 4 bonds are appear around the nitrogens only. Okay, maximum is phosphorus will be 6 will be there, arsenic 6 will be there, stibinium 6 will be there, PCl 6. PF6 is there, no? That's one example. Next, maximum covalence nitrogen is 4, phosphorus 6, arsenic 6, stibinium 6 only. PCl5 is there, no? Covalence is 5 due to the excited state of the electronic configuration only. General P, if you take the PH3, its covalence is 3 only. But because of availability of d electron, the electrons under excitation will take place, so they can exhibit the PCl5, PCl6 due to the availability of the d orbital. Do you know very well? Whenever any element containing the vacant d orbital, its covalence will be expand its valence. Generally, it will be expand its valence only. When you go for next slide here, just consider next slide is there. No question is there. Why bismuth having the covalence 3? Look at the bismuth electron configuration is 6s2 6p3 only. Due to inert pair effect is there. No inner 6s2 electrons do not take part in bond formation. That's the reason why bismuth having the +3 oxygen is more stable state. That's why its covalence is 3. That's why its covalence is 3. Next one is atomicity of the nitrogen. Look at the catenation. What is catenation? It is the binding of an element to itself through a covalent bond only. Okay. Generally, wherever carbon having the highest catenation capacity. Next, coming to the catenation capacity of the remaining elements also. You can answer is there no general nitrogen having the catenation capacity is 3 only. N3 molecule possible. Okay. Next one is atomicity of number of atoms present in a molecule. Atoms are the number of atoms present in a molecule. A nitrogen containing of 2 atoms are there. Phosphorus containing of 4 atoms. Arsenic 4 will be there. Bismuth 4 will be there. General because strontium 4 will be there. General bismuth is a metal only, no? So you cannot say like it is a monatomic only. Once again repeating it, the atomicity of nitrogen 2, phosphorus 4, arsenic 4, strontium 4 only. Bismuth having metallic nature is then that's why it's monoatomic only. Generally it is a monoatomic nature only. Next one is there here the sulfur example. Okay, just consider why nitrogen not forms N4. Why do not form N4 means look at it because the why next question is there no why nitrogen do not show the catenation is there. Catenation property is proportional to the strength of single bonds only no, between the atoms only no. Strength of single bond between the atoms only. Because due to small size of nitrogen that's belong to second period element, there is a repulsion between the lone pair of electron repulsions are there no. That's why what I mean here the repulsion of nitrogen atom and single bond strength will be decreased only. That's the nitrogen forms triple bond only. Okay, because of electronic repulsions, nitrogen cannot form cannot form as N4. And also can say that due to lack of the d orbital, it cannot also form here. Next one is the boiling point only. General nitrogen, phosphorus, arsenic, antimony, bismuth. You can see the boiling point is there. No? Down of the group is increased only. Bismuth having high boiling point. Why? Because of means no, it's a metal, so it has high boiling point only. Next TBM. Next look at here small variation. Ammonia is coming. Why ammonia is coming? Why can't phosphorus means here? Because of ammonia having the hydrogen bonding. Because of ammonia having hydrogen bonding, it is having high melting point and boiling point will be also will come here. Next one is consider the one point is that here the thermal stability. Look at on going up down of the group what I mean there thermal stability will be decreased. What thermal stability? But the bond between the bismuth and hydrogen is very weak when compared with the ammonia bond only. Why ammonia bond means here nitrogen more electronegative atom, it pulls electrons very strongly and also possibility of formation of hydrogen bond only no. So thermal stability because ammonia is more, next phosphine is there, next arsenic is more, next TBM is more, next bismuth is more. Thermal stability look at the thermal stability decrease in the group only. As we go down of the group what and the atom becomes larger size, so the overlapping between the orbital is not much enough. So what I mean there the bond will be become weak only. So when now thermal stability is decreased, what I mean the reducing power is increased only. So when you come to reducing power, what I mean there the bismuth having highest reducing power. You can also say the bismuth is a metal only no, it can readily donate H plus atom. So what I mean the reducing character of the compounds will be more with the release of the whenever the more tendency to lose the hydrogen atoms, more tendency for reduction process only. More tendency for reduction process only. Since down the group what I mean there it become the bond strength between the metal and hydrogen will decrease only. They can readily give hydrogen atom. So what I mean there down of the group the reducing property will be increase only. Down of the group the reducing property will be increase only. Next come to basic nature. One point is student lot of students the last question. Sir here metal is there no, bismuth is metal, its hydride will be basic nature. Why ammonia having highest basic nature? Why? Because of means here the ammonia containing of lone pair of electrons. Because of lone pair of electron it acts as Lewis base only. It acts as Lewis base. You could consider the metal bismuth hydrogen is there no, less denser of lone pair of electrons are there no, it cannot act as a best base nature. That's the reason why ammonia having the strongest basic nature only. Ammonia having the strongest basic nature. Once again repeating, because of lone pair of electrons ammonia act as a best base only when compared with bismuth only. When you go for down of the group the basic nature will be decreased only. When you go for down of the group the basic nature will be decreased only. Next one is bond angle. Bond angle depend upon the electronegativity of element only. More electronegativity, more bond will come here. You could consider the ammonia is there no, nitrogen atoms are more electronegativity. The bond pair of electrons moves towards nitrogen because of there is repulsion between the lone pair of electrons and bond pair of electrons. Bond angle for the ammonia is more when compared to the remaining elements only. Down the group bond angle will be decreased only. Okay now bond angle is then a direct proportion to the electronegativity of central atom. Okay, which means more electronegative means nitrogen having the most electronegative only. So bond angle is more for the ammonia only. Next one is the consider the reaction with the oxygen. You know very well oxygen is the most reactive element only. Oxygen can react with all elements only. They forms two types of oxide, +3 oxide, +5 only. Remember N2O3, P2O3, AS2O3, Sb2O3, Bi2O3. And also here is the N2O5, P2O5, AS2O5, Sb2O5, Bi2O5. They forms variable types of oxides only. Remember first one is the here Sdic oxide. Next one is Sdic oxide. Somewhat amphoteric oxide. Next one is then here what we consider the here basic oxide only. When you come to +5 oxidation is the what I mean there here the Bi2O5 is become acidic nature only. The one point remember why acidic nature, here basic nature, why acidic nature means here the because of increasing of oxidation number. The oxidation number varies from the +3 to +5 only. Because of increasing oxidation number, the nature of the metal oxides also decreases only. Remember here the whenever the element having the